All right, let's work on the solution for the quiz 1. The first question says there are 6 workers, 1 at each station, and then the processing time for each station is given: 44 seconds, 40 seconds, 55 seconds, 60, 50, and 40. That means the capacity is 1 by 44, 1 by 40, 1 by 55, 1 by 60, 1 by 50, 1 by 40. The reason we were able to do that is because there's only 1 worker in each station. The capacity is expressed as unit per second. Well, we can see that this is the slowest capacity. That's why D is the answer. Well, the next question asks, what is the process capacity in terms of razors per hour? Well, the process capacity is given by the bottleneck step. The bottleneck step has a capacity of 1 by 60 units per second. So this must be the capacity of the process, but the answer should be in razors per hour. Well, we can, to convert from units per second to units per hour, we can multiply this by 3600 seconds, because there are 3600 seconds in 1 hour. Well, you get 60 razors per hour. The next question is, what's the direct labor cost associated with producing 1 razor? Well, the direct labor cost, because there are 6 workers and each of them gets paid $25 each, the top is $25 multiplied by 6 workers, but the flow rate, which is the same as the process capacity, is 60 units per hour. Why do I use the hour one? Because the wage is expressed in terms of hour here, $25 per hour multiplied by 6 people, and there is 60 units being produced each hour. That's why we have 150 divided by 60, which is about $2.5 per razor. Next question is, what's the average labor utilization? The average labor utilization is, well, the easier way to do this is altogether, if you add this 44 seconds, 40 seconds, 55, 60, 50, and 40, you get 289 seconds. In the bottom, well, each of them had 60 seconds to work with, but the first person worked only 44. That means there is a 16 seconds of idle time. The second guy had 20 seconds of idle time. You can do that way, get all the idle time and add 289 seconds plus idle time. Or you can just say, well, there are 6 workers and each had 60 seconds possible work time. That is 6 into 60. That is 289 divided by 360. Okay, which is about 80%. All right, let's get to the next part of the quiz. Let's change the color here. Let's work with blue now. All right, the question says, how many days on average does a product stay in Save-A-Lot's inventory? Well, we can first, you can find that there are quite a few ways to do this. One way is the inventory turn equals to COGS divided by inventory. In this case, 53962 divided by 5743. This turns out to be about 9.39. What that means is the inventory on average turns, the company turns the inventory about 9.39 times, but the answer is not done because the question asks you not the inventory turns, but how many times each inventory stays there. So in terms of days, so there are 365 days. You divide that by the number of inventory turns, you get about 38.84 days. The next question was a little tricky. The question says, well, for both the retailers, the COGS is $50, right? And both of them have the same holding cost of 20%. Then how much is the holding cost per unit for both for each of the retailers? Well, first, the holding cost per unit per year for both the retailers is $50 multiplied by 20%, right? That is equals to $10. But what is the inventory turn? Well, the inventory turn for Save a Lot, we already calculated it. That is, in turn is already we calculated, that is 9.39. Whereas for Wally's Mart, the inventory turn is 316,606 COGS divided by inventory of 40,694, which turns out to be about 7.78. Well, Wally Mart flips the inventory 7.78 times a year, and Save a Lot flips the inventory 9.39 times. The holding cost is $10 per year, so the per unit cost is just 10 divided by 9.39, which is same as saying 1.06, whereas here the holding cost is $10 divided by 7.78, which is 1.28. Well, you can find the difference. The difference is 1.28 minus 1.28 minus 1.06, which is about 22 cents. The next question, this is the question we already did in the class. In the pizza restaurant, the average customer orders 30 pizzas an hour. So this is rate equals to 30 pizzas per hour, 30 units per hour. The time that it stays in the system or the oven is 10 minutes. So the question is, what is the inventory? Well, I equals to R equals RT, which is R is 30 units per hour multiplied by 10 minutes. Well, the problem is the units are in, this is in hour, this is in minutes, so we want to convert 30 units per hour multiplied by, convert this 10 in terms of hour, that is 10 divided by 60, which is same as saying 1/6. So 30 divided by 6 equals to 5. So D is the answer. The next question was the pretty tricky one. The 4 dimensions the operations are. We never talked about ethics. Well, obviously A is not the answer. Well, global footprints sounds pretty made up too. So the answer had to be between B and C. The only tricky part here was in B, you had efficiency and cost, which is exactly the same thing the way we have defined in our first chapter. So the B has efficiency, variety, responsiveness, and quality. So we introduced this as a cost in the class, but we also explained that it is same as saying efficiency. Answer is C. The next question, which a lot of people got it wrong, but again it is nothing but just interesting numbers. It is a little slow problem, right? What I've asked is, the rate is 4,000 units per hour, right? And I said the T is 62 minutes. Then what should be the inventory, right? That's what I've asked. How large is the oven required? Answer me in terms of units breads per hour. Okay, so I is, rate is 4,000 units per hour, time is 62 minutes. Again, the same problem as we had earlier. Here is hour, here is minute. We want to convert this minute in terms of hour. We can do this by dividing by 60, right? If we could divide the minutes by 60, it becomes hour. So now this is hour. So 4,000 multiplied by 62 divided by 60 is nothing but 4,133.33. So the inventory in the system would be on average 4,133 units of bread. So the inventory must be at least this large. Okay.